So for our next topic, we will going to discuss about tension members. So, eto yung mga forces natin na acting away dun sa mga structural members natin. Kaya nga sinabi nga yung mga forces natin is in tension lahat. Is in tension lahat ng i-consider natin for this analysis. So we have two forces, no, kung paano sila nag-a-act. So first of all, is yung tension na pag-aaralan natin. And also yung another na pag-aaralan natin na compression member is yung column naman. So for this, we will going to focus muna sa tension member. So let's solve problem number 1. A 130 mm by 12 mm plate is used for tension member. So meron tayong plate dito. So yung 130 mm, ito yung width ng plate. And yung 12 mm naman, that is the thickness of our plate. So kung titingnan natin sa side, etong plate natin, so this will now become your 12 mm, yung thickness niya. And yung width naman ng plate natin, that is equal to 130 mm. So malalaman natin na tension yung mga members natin once na nakita natin na etong force natin is acting away dito sa structural member natin. So, siyempre, yung connection natin para mapagdikit natin yung plate natin dun sa mga structural members natin, more specifically sa mga ginagamit natin na gusset plate, is yung mga bolts natin. So, for this one, it is connected to a gusset plate with 4 16 mm diameter bolt as shown. So, for this problem, meron tayong 4 na bolts. So, kinonect niya itong plate na to dito sa gusset plate. So, for this problem, we're going to assume na yung effective area mo is equal to the net area. So, mamaya pag-uusapan natin etong dalawang to. Fy is 248. Since 248 megapascal yung Fy mo, you are considering 836. So usually, ito yung ginagamit natin, yung 836 steel. And Fu is equals to 345 megapascal. So using NSCP 2015 provisions, so we will going to determine the design strength. So kapag sinabi natin design strength, so we are talking about LRFT. Kapag naman allowable, yung sinabi, or the allowable strength, we are talking about ASD naman. So for this one, gagamitin natin yung dalawang approach natin to solve for the value ng design strength and the allowable strength. So, sa mga tension members natin, so meron tayong dalawang limit state na sinusundan or kino-consider. So for this one, we're going to consider these two limit states. So una is based on gross area muna. So based on gross area, so kapag gross area yung kino-consider natin, from the word itself, gross, yung mismong nakuha nating area. So, when we are considering the gross area, so yung kinukuha natin dito is yung yielding. So, next naman is the based on net area naman. So, susunod naman dito is the based on net area. So, for this one, kapag net area yung kino-consider natin, so, under tayo sa rupture. So let us discuss first yung yielding muna. So yielding of the cross section. So for this one, yung nangyayari kasi kapag kinukuha natin yung mga design strength natin, kukunin muna natin yung nominal natin. So for this one, we have nominal. So yung nominal tensile, yung nominal natin na force that is equal to, so yung ko-consider natin dito is yung gross area natin. So kapag kumukuha tayo ng mga forces, so yung stress natin that is always force all over area. So meaning to say, para makuha mo yung force mo, you need to multiply yung stress natin dito sa area natin. So for this one, under sa yielding, we are considering yung gross area. And yung stress na gagamitin naman natin is yung Fy naman. Kaya nga sinabing yielding. So yung gagamitin natin is the value of your Fy. So for this one, so let's solve first for the value of your gross area. So yung tinutukoy natin na gross area dito is yung area na perpendicular or acting normal dito sa force natin. So for this one, so kung titingnan natin dito sa side view, so eto ngayon yung force T natin. And the perpendicular area na i-consider natin is yung area ng buong plate natin. So yung width ng plate natin multiplied by its thickness. So we have 130. Multiply natin siya sa thickness na 12. So you will have a value of 1,560 square millimeter. So for this, makukuha na natin yung nominal natin. So that is equal to Fy na 248 megapascal multiplied by yung gross area natin na 1,516. So yung value ng nominal natin, that is equal to 386.88 kilonewton. So this is on gross area tayo dito. Okay. So yung next na limit state naman natin is yung sa rupture naman. So when we are dealing with rupture, mangyayari is there is separation. So yung ko-consider naman natin dito is yung net area naman natin. So yung nominal natin as designated by the subscript of N is equal to, so yung net area yung i-consider natin dito. So upon considering dun sa net area natin, yung gagawin natin is kukunin natin yung effective area natin. And then yung stress na imumultiply natin sa area, yun naman yung tinatawag natin na value na Fu. So for this one, yung mangyayari kasi, bago mo kasi makuha yung value ng AE mo, that is always equal to reduction factor multiplied by the net area. So, since dito sa problem natin, sinabi dito na assume that the effective net area is equals to the net area natin. Kaya, hindi na natin kinuha yung value ng reduction factor natin. So, under dito sa limit state natin sa rupture, so sinasabi niya dito na may effect yung mga butas caused by the connection natin sa mga holes natin. Kasi, yung tendency kasi, kapag meron tayong mga butas, yung area ng plate natin nagdi-decrease. kung titingnan natin dito, kung i-consider natin etong plate natin, so, kung babalikin natin yung formula natin, stress is equals to force all over area and kukunin natin yung value ng force natin, that is stress multiplied by area. So, meaning to say, kapag nag-i-increase yung value ni area, tumataas yung value ni force. And at the same time, so meaning to say, tumataas yung capacity ng force natin. Or kung dito naman tayo titingin sa stress naman, so dito tayo titingin, dito sa formula natin. So kung tataas yung area natin, the value ng stress naman natin is bababa. Kasi ang mangyayari is inversely proportional yung stress at saka yung area natin. So for this one, what I'm talking about is kung magde-decrease yung area natin, yung mangyayari sa value ng nominal natin, bababa. So since magde-decrease yung area natin, bababa yung nominal natin. Kasi ileless na natin yung area caused by the bolts. Kasi yung consider natin dito sa net area is yung critical part. So for this one, yung consider natin is etong section na to. Ayan. So kung titingnan natin etong section na to, po-project natin siya, eto yung mangyayari. Eto yung makikita natin. So etong shaded by red, eto naman yung butas natin or yung hold. So kunin muna natin yung value no, effective value no net area natin. So for this one, meron tayong given na bolt diameter. So yung bolt diameter natin, that is equal to 16 mm. So yung bolt diameter natin, that is 16 mm. And meron tayong tinatawag dito na nominal hole dimension. So for this one, that is denoted by D sub n. So yung nominal hole dimension natin, so that is meron tayong allowance na 2 mm based sa NSCP 2015. So mangyayari meron tayong diameter bolt ng 16 mm. So maglalagay tayo dito ng allowance na 2 mm. So mangyayari yung diameter ng yung nominal hole diameter natin o yung butas natin, that is equal to 18 mm. And also meron tayong tinatawag na diameter of hole, that is denoted by D sub h. So mangyayari is yung sa nominal hole diameter natin na nakuha natin na 18 mm, so maglalagay pa tayo dito ng another na allowance na 2 mm. So the value of your diameter of hole is equal to 20 mm. Kasi para mag-connect etong bolts natin at saka yung plates natin, yung ginagamit natin is hindi naman natin bubutasan yung plate natin ng saktong 16 mm. So maglalagay tayo ng allowance. So for this one, so let's say no, ito yung diameter ng hole natin, diameter ng bolt natin. So yung tendency is maglalagay tayo dito ng allowance na tig to 2 mm. So mangyayari is ito na yung mako-consider natin na diameter ng mismong hole natin dito sa plate natin. So after computing for the diameter of the hole, so kukunin na natin yung value ng net area natin. So for this one, so let's solve for the value of your net area. A sub n is equal to, so consider muna natin itong width natin. So yung width muna natin, yung kabuang width natin dito sa section na to, that is equal to 130 minus, so kung matitingnan natin dito sa side na to, meron tayong dalawang hole. So 1, 2. Etong shaded by red, so we have 2 multiplied by, so ano yung dimension? Ano yung width ng hole natin? So that is equal to 20 mm. So yung kada butas natin, meron niyang width na 20 mm, 20 mm. Kaya kinuha natin yung net width. So meron tayong 20 multiplied by, since kumukuha tayo ng net area, so multiply natin yan sa thickness, which is equal to 12 mm. So for this one, the value of your A sub n is now equal to 1,080 mm squared. And hindi naman to agad-agad yung gagamitin natin dito sa Rapture. So, gagawin natin is para makuha natin yung effective area natin, imumultiply pa natin ng reduction factor etong net area na nakuha natin. Since dito sa problem, sinabi na assume A sub E is equals to A sub n, so eto na yung gagamitin nating value ng A sub E. Then, yung A sub n naman natin, meron tayong limit dyan. Your A sub n, that must be less than to 0.85 of Ag. For this, yung 0.85 Ag natin, that is equal to 0.85 multiplied by yung Ag natin doon na 1,516, which is equal to 1,326. Since less than yung value ng A sub n natin dito sa 0.85 Ag, so okay yung consideration natin. So, makukuha na natin yung value ng nominal, natin. So, considering yung Fu natin, which is equal to 345 megapascal, multiplied by the effective net area, which is equal to 1,080. So the value of your nominal is now equal to 372.16 kilonewton, considering the net area. So, nangyayari kasi sa mga stresses natin, nagkakaroon tayo ng mga critical talaga sa mga part natin kung saan may butas. That's why, nileless natin yung mga butas natin dun sa gross section. So, kung gagawin natin ng summary sa pagkuha ng net area, so yung ginagawa natin dito is, kinukuha muna natin etong net width natin. And minumultiply naman natin siya sa thickness. So, lagi lang natin kinukuha yung net width and then we multiply by the thickness para makuha natin yung net area. So, after computing for the value of your nominal, so, kukunin na natin yung design tensile strength and the allowable tensile strength. So, for this one, gagamitin natin yung LRFD at saka yung ASD approach natin. So, we will going to consider both design method in computing for the values ng design strength and the allowable strength. So, meron tayong nakuhang dalawa. So, etong P sub n natin sa gross area and the P sub n natin dito sa net area naman. So, gamitin muna natin etong sa LRFD natin. So, para makuha natin sa gross area to, so, para makuha natin yung design strength natin, so yung ginagawa natin dyan is that is equal to PU or equal to reduction factor multiplied by the nominal. So for this one, yung reduction factor natin on the gross area, that is equal to 0.90 multiplied by yung P sub n na nakuha natin, which is equal to 386.88. So the value of your design strength, that is equal to 348.19 kilonewton. And dun sa kabila naman, which is yung ASD naman, so para makuha naman natin yung allowable strength, yung ginagawa natin dun sa nominal na nakuha natin is dinidivide natin yan sa factor of safety. So for this one, ito yung tinatawag natin na allowable strength. So yung P sub n na nakuha natin, which is equal to 386.88, dinidivide natin siya by a factor of safety na 1.67. So yung makukuha natin na allowable strength is equal to 231.66 kilonewton. Then next naman, ito yung mga design strength natin sa gross area and the allowable strength naman sa gross area. So susunod naman, we're going to solve for the value of your design strength naman considering the net area or yung rupture natin. So, same principle lang, para makuha natin yung design strength, which is yung P sub u natin, we will going to multiply a reduction factor dun sa nakuha nating nominal. So, for this one, kapag kino-consider natin yung net area, yung reduction factor natin, that is always equal to 0.75 multiplied by yung nominal na nakuha natin, that is equal to 372.16. So the value of your design strength is now equal to 279.45 kilonewton. On the other hand naman, using ASD naman, so kapag kinukuha natin yung allowable design strength natin, which is denoted by P sub A naman, that is always equal to P sub N divided by the factor of safety. So, yung nominal natin, that is equal to 372.16. And yung factor of safety natin, under sa net area, considering yung rupture, is equal to 2. So, the value of your allowable strength is now equal to 186.30 kilonewton. So, ito yung sa design strength natin at saka yung allowable strength. So, considering the two limit state, siyempre yung consider natin dito is the smaller value. Yun yung magiging answer natin. So, for this one, meron tayong dalawang values dito sa gross area. Considering dalawang values considering gross area, which is equal to 348.19 kilonewton, and the net area naman, which is equal to 279.45 kilonewton. Siyempre, yung i-adapt natin dyan is yung list yung value natin. So, ito yung magiging answer natin or ito yung magiging design strength natin. So, laging list yung value na kino-consider natin kasi nga, kung i-adapt natin etong 348.19 dito sa net area natin, yung tendency is masisira yung plate natin dito sa net area natin. Kasi hanggang 279.45 kN lang yung kayang dalhin ng plate natin considering rupture. So, on the other hand naman, eto naman kung i-consider natin, i-adapt natin yung 279.45 kN, so kaya siyang dalhin ng plate natin sa gross area. Kasi nga, yung kayang dalhin ng plate natin is hanggang 348.19 kN. So, same principle lang tayo dito using ASD. So, we have etong sa allowable strength natin na nakuha considering gross, that is 231.66. Considering net naman, that is 186.3 kN. So, for this one, ito yung consider natin, yung lesser value. So, this will now become your allowable strength.